Have you ever wondered how computers think? I mean, they don't have brains like ours, do they? Instead of using words and numbers like we do, computers speak a special language called binary. Imagine a world where everything is communicated with just two simple digits, 0 and 1. That's binary. Binary is the language of computers because it's the simplest way to represent information electronically. Inside every computer, there are tiny switches called transistors. These transistors can be either on or off, just like a light switch. On is represented by a 1, and off is represented by a 0. Think of binary like a secret code. It's a language that computers use to communicate with each other and with us. Each digit in a binary number, whether it's a 0 or a 1, is like a clue that helps us understand what the computer is trying to say. These digits are the building blocks of all digital information. These zeros and ones are combined in different ways to create all sorts of information, from numbers and letters to images and even music. Imagine how versatile this simple system is, enabling everything from simple text messages to complex video games. Let's take a look at a simple binary number, 101. This number might seem small, but it holds a lot of meaning. Each position in this number represents a power of 2, starting from the rightmost digit. This positional value system is what gives binary its power. The rightmost digit represents 2 to the power of 0, which equals 1. This is the foundation of how binary numbers are calculated. The next digit to the left represents 2 to the power of 1, which equals 2, and so on. Each step to the left increases the power of 2, allowing us to represent larger and more complex numbers. Now let's decode that binary number, 101. Binary numbers are the foundation of all computing systems, and understanding them is crucial. Remember, we start from the rightmost digit and move left. Just like reading a book from right to left in some cultures, with each position representing a power of 2. This is because binary is a base 2 number system, unlike the decimal system which is base 10. So, 101 can be broken down like this. Each digit is multiplied by 2 raised to the power of its position. 1 times 2 to the power of 2, which is 4, plus 0 times 2 to the power of 1, which is 0, plus 1 times 2 to the power of 0, which is 1. That equals 1 times 4, plus 0 times 2, plus 1 times 1, making it 4 plus 0 plus 1, which equals 4 plus 0 plus 1, giving us 5. This method is systematic and can be applied to any binary number, that's it. The binary number 101 is equivalent to the decimal number 5. Understanding this conversion is fundamental in computer science. We can use this same method to convert any binary number to its decimal equivalent. Practice makes perfect, so keep decoding those binary numbers. Section 4, ASCII, from numbers to letters and beyond. But how do computers represent letters and other characters using only zeros and ones? This is a fundamental question in the world of computing, and the answer lies in a clever system that bridges the gap between binary code and human-readable text. That's where the ASCII table comes in. The ASCII table is a standardized way to convert binary sequences into characters that we can understand and use. ASCII stands for American Standard Code for Information Interchange. It was developed in the early 1960s and has since become a cornerstone of digital communication. It's like a giant code book that assigns a unique binary code to each letter, number, and symbol we use. This allows computers to translate binary data into text that humans can read and understand. For example, the capital letter A is represented by the binary code 01000001, which is equivalent to the decimal number 65. This binary to decimal conversion is crucial for the computer to process and display text. The lowercase a is represented by 011000001 or 97 in decimal. Each character has its own unique binary code, making it possible to represent a wide array of text. The ASCII table allows computers to store and process text, which is essential for everything from writing emails to browsing the web. Without ASCII, the digital communication we rely on every day would be impossible. Section 5. Binary's impact, the foundation of the digital age. Binary is the foundation of the digital age. It's the language that allows computers to store, process, and transmit information. Without binary, we wouldn't have smartphones, laptops, the internet, or any of the other amazing technologies that we rely on every day. Understanding binary gives us a glimpse into the inner workings of computers and the magic of the digital world. So next time you're using your favorite gadget, take a moment to appreciate the power of zeros and ones that make it all possible.